Thank you, everyone. It's a pleasure to be here. So today I'm going to be focusing more on the utility of predictive modeling for understanding the impact of public health policies that are focused on improving and reducing obesity rates. These are my disclosures. And today, first I'm going to start by going over what do public health policies for obesity look like. So I kind of dug into the CDC's database that really lists all of the proposed, in process and enacted policies at the state and federal level to understand and impact obesity. And then I'm going to talk about a framework that I think can be utilized to really flesh out predicting the impact of such policies. And then finally, I'm going to review the evidence for some of the assumptions that are outlined in that framework to, I think, really help us understand why it's so important that they're included in the modeling for public health outcomes when it comes to obesity. So to clarify, I'm going to narrow our discussion a little bit today on only policies that essentially try to influence body weight and specifically reduce body weight by either changing energy intake or changing energy expenditure at an individual level. So I'm not going to discuss all policies around prevention of weight gain as much as I am going to be discussing the framework for understanding the impact of policies on reducing an individual's body weight and therefore seeing a change in obesity rates at a population level. So that's a very specific thing we're examining today. So if you comb through the CDC's database of currently enacted policies, I kind of group the policies that are out there into three different types. The first one usually is a policy to reduce a specific source of calories. I think the most common and the most famous, prevalent one in the media in that regard would be policies that tax sugar-sweetened beverages. And this is currently in practice in 33 states. And the rationale is that if you tax sugar-sweetened beverages, then that would reduce calories from sugar-sweetened beverages. And we do have some data, excuse me, to suggest that taxing sugar-sweetened beverages will reduce, most of the studies report, between 20 and 40 calories reduction of consumption of sugar-sweetened beverages. And so we have some data to suggest that things get that far. The other type of policies usually focus on increasing energy expenditure through really the most manipulatable source of energy expenditure, which would be through physical activity. So for example, in Arkansas, just in 2016, a new law has been enacted to enforce very specific amounts of moderate to vigorous physical activity that have to occur in the school physical activity setting. And so, for example, in kindergarten through 6th grade, they're required now to get 90 minutes of physical activity per week. So of course, theoretically, that would increase physical activity and energy expenditure, therefore reduce body weight and obesity. Now, the third kind of policy is a little bit different in that the idea with these policies is to increase the availability of healthy foods. And that would then theoretically lead to a reduction in calorie intake. So this, for example, would include improving drinking water availability and perhaps having drinking water availability so that people can quench their thirst without having a calorie-containing beverage. Another example would be reducing barriers to roadside stands for selling fruits and vegetables so that people can have more access, or perhaps supporting farmers markets, or educational programs that encourage healthy food choices. And again, the rationale here is that eating that healthy food will lead to overall reduced calorie intake in the general public. So let's kind of break that down. What does that look like from rationale to actual weight change? The first step, of course, I think a lot of times we do go as far as verifying that taxing sugar-sweetened beverages reduces calorie intake by 20 calories from that particular calorie source. Now, the next assumption we're going to be making is that those 20 calories of sugar-sweetened beverages is not replaced by another calorie source, right? Because it has to be a reduction in the overall energy intake to impact body weight. And then we would be assuming that that calorie reduction is then not countered by an increase in appetite or by a change in energy expenditure, so that then weight is actually impacted to a significant clinically meaningful extent. So I see two kind of common issues with the public health policy approaches that I have outlined and I see as most common. The first issue is that they don't really account for energy balance being a dynamic, adaptable system. And also, I find that most policies will focus on a single food or a single habit rather than focusing on a policy that would create a substantial, persistent shift in someone's overall energy balance. So I think we're often making the assumption that changing one small behavior will tip the energy balance scale on a chronic, persistent basis. I think it would benefit by asking, does that really happen? So let's go talk about the framework that I had mentioned. So here I propose a probability model for those type 1 and type 2 policies that focus on either changing caloric intake from a specific source or increasing energy expenditure. So step A would be the probability that that policy actually changes those behaviors and therefore the calorie expenditure or intake. And often, again, we go that far, right? We know that that at least happens. But step B would be the probability that there's compensation for this change through either consuming other foods or through other physical activity changes occurs. Next, we would need to account for the probability that there's some physiological adaptation to appetite or energy expenditure to counter those changes. And then finally, we would have the final probability that body weight is lost. And so you see, this is really a joint probability model here, where the probability of each step kind of depends on the probability, or is, adjusted by the probability of the previous steps. Then we finally have a slightly different model for type 3 policies, because here we're really talking about, we're hoping for a replacement, where we're hoping for that a unhealthy or energy-dense food is replaced with a healthier food. So this would look a little different, where first the policy actually manages to increase consumption of the target food. So for example, farmers markets, people actually buy and then consume those foods. Next, that calorie intake is reduced because the target food replaces another higher calorie food. And then finally, again, we would have to account for those either behavioral or metabolic adaptations that might occur in response to that perturbation in energy balance. And finally, we would see that body weight is lost. So let's talk about some of these steps that I've outlined. How critical is it really that we account for these? So I'm going to bring us back to kind of our general rule of thumb that is often used for predicting outcomes for public health policies, and that's the 3,500 calorie rule. And that makes the assumption that a reduction in energy intake has kind of in a static model would result in a kind of not adapted to reduction in body weight, because 1 pound of body fat equates to 3,500 calories. But when we look at this and compare what the 3,500 calorie rule would predict in response to a 40 calorie reduction in sugar-sweetened beverage intake from a sugar-sweetened beverage tax, what we see is the red line there is kind of this static model, the 3,500 calorie rule prediction. And what Dr. Kevin Hall and others have demonstrated is that the dynamic model that they have built that accounts for metabolic adaptations actually would show a very different line, and it's the blue line there, where accounting for at least metabolic adaptations to a perturbation in energy balance would mean that, unfortunately, only 1.8 kilograms would be lost over the course of 5 years, instead of the 9 kilograms the 3,500 calorie rule would predict, and that most of that weight is lost within that first year. So that's when we account for those metabolic compensations. So for example, when body weight is lost, we need less energy to support the lower energy stores, or the increase in metabolic rate, or excuse me, the increase in efficiency of metabolic rate as we lose body weight. And what about behavioral compensation? I actually work in a department of kinesiology, and one of my students shared this with me because this is the reason she's interested in kinesiology, and the reason she exercises every day is because she likes to eat. So I think a lot of times we make the assumption that if we increase physical activity, that wouldn't be countered by some increase in appetite. But is that really true? Let's talk about that. So we see that we've conducted a study where we tried to kind of quantify the behavioral compensation that might occur and see, is there evidence that this exists? And so what we did in this analysis was we collected studies where free-living individuals had one aspect of their energy intake or their energy expenditure altered. And we were reasonably sure that happened because it was objectively verified and they were highly compliant. And everything else was left free to vary. So for example, if they were asked to exercise, their diet was not changed. They were allowed to compensate for that exercise by increasing their food intake. Or if a food was added to their diet, for example, that someone wanted to see the effect of almonds on health, they also happen to report weight change in those studies. And so we can see if you just add one food to the diet, like often public health recommendations suggest, start eating this food. It'll help your weight. So then what happens to actual weight change when everything else is left free to vary? They're allowed to eat whatever else they want throughout the rest of the day. These aren't isocaloric comparisons we're talking about here. And when we compare the actual weight change in those studies to the predicted change from the dynamic models that account for all the metabolic compensations that happen, this is what we see. We see that the weight loss is about 60 to 65% less than what you would expect from both the Pennington model that Dr. Thomas has built and the model that Dr. Hall has built from NIDDK. So again, those models are built to predict things in clinical settings where you change one thing but everything else is held constant. But that is not the case in the free living population that these public health policies are intended for. And it seems that there might be some effect of what kind of policy there is. So for example, overfeeding studies where you add a food to the diet actually produce very little weight gain. 6% of what would be predicted, very, very less. Exercise studies only produce about 45% of the predicted weight loss from the dynamic models. And diet intervention studies produce 88% of the predicted weight loss. Now, one caveat to those is we weren't able to find any studies, dietary studies, where the diet interventions allowed for dietary compensation. All of those studies only allowed for compensation through physical activity because the food was offered and provided in that instance. And this model we have basically offered on the UAB NORC's website, and so you can find it there, where basically you take the prediction from one of Kevin or Diana's models, and you plug in that prediction here, and it corrects it for this kind of behavioral compensation. And so that's available if you'd like to play with that. And another recent paper, again by Dr. Hall, that came out suggests that there's some really nice quantified idea here from this study of how much do we increase our appetite in response to a certain amount of weight loss. Again, suggesting that as we lose weight, the appetite increases and we do, in fact, eat more. So this study compared a placebo group to a canagliflozin trial where these individuals lost glucose through the urine and therefore kind of covertly were losing calories and therefore losing body weight. And what you see in panel A there is that, not surprisingly, with that treatment, people do lose weight over about 24 weeks' time. But then interestingly, panel B demonstrates that the placebo group doesn't have a large change in energy intake, but you can see that with every kind of incremental decrease in the body weight of individuals on the treatment, the appetite will increase to kind of start to counter that weight loss. And it seems that that amount is about 100 kilocalories per day per kilogram of weight loss. So that's a great example of, again, that kind of behavioral manifestation of increased appetite, increased food intake in response to a certain amount of weight loss, suggesting it's really important that we're accounting for these considerations. So models that don't account for both will likely substantially overestimate weight change resulting from public health policies that are trying to influence one aspect of energy intake or energy expenditure. I'd like to just take a moment also and discuss a separate issue about the type 3 interventions. So with those, we're really trying to increase availability of the healthy, lower calorie foods, and bringing us back to that probability model that I discussed. I think a lot of times we see policy A, right? We do a study to suggest, okay, the policy does actually increase the consumption of the healthy food. That's a good first step. But then the step B is often not necessarily followed up on and understood, in that, does that target food actually replace another such that caloric intake is actually reduced, and is that a sustainable, persistent thing that occurs? And so I would say, what do we need to do to really look at this, and why do we make this assumption in the first place? So I think a lot of times we assume that eating a specific food would be helpful to reduce energy intake because of studies that demonstrate either consumption of that food is associated with body weight in epidemiological studies, so that seems like a good solid piece of evidence, or perhaps the consumption of that food in a single ad lib meal reduces energy intake relative to when that food is not offered. So again, that's kind of solid and suggests that would be good. Or maybe consumption of the food on a given day or over several days has actually been shown to change 24-hour ad lib energy intake relative to a day when that food is not consumed. Or finally, maybe one or more components of energy expenditure are different on days when the food is consumed relative to days it's not. So, these are kind of the studies we tend to base these recommendations on. But I want to point out that none of these studies are actually sufficient evidence that eating a specific food would actually produce a persistent significant reduction in calorie intake that's not compensated for. We stop short of that every time. So in a recent publication, I kind of described how would we actually be able to prove that this probability of step B, or that one healthy food replaces another such that caloric intake is reduced. So really, I think we need to do these studies where we recruit the general population the policy is intended for, actually manipulate the level of the food we're interested in, like the intake level, in a way that's controlled, objectively verified, and carefully done. Let them have that manipulation for enough time to see a body weight change, and then actually measure the change in energy intake as a result of eating this food, or the change in body weight. So in a study, again, that Dr. Hall was involved in, they did kind of try to do this, where they replaced sugar-sweetened beverages with sugar-free beverages over an 18-month period. And they did demonstrate that there was a significant reduction in energy intake by kind of looking at weight change throughout the period and back calculating the change in energy intake as a result of this policy. And interestingly, what they showed was that people in the high BMI category of these are children and adolescents, actually demonstrated less compensation for the covertly removed sugar-sweetened beverage calories. So this is the kind of study where we can actually start to quantify, I think, the impact of these policies on actual, measurable outcomes and changes in energy intake, and therefore eventual changes in body weight. So this, I think, is a great example of this kind of replacement study that would really inform very well public health policies to reduce obesity. So in summary, I think many current public health policies may be overpromising their impact on reducing obesity using the 3,500 calorie rule. And I think that there's a mounting evidence that metabolic and behavioral compensations are significant enough to where they really do need to be accounted for when we're trying to impact BMI at a population level. And then finally, I think one of the most important findings from the meta-analysis we did, where we compared weight change between observed and predicted outcomes, was that there are a paucity of studies that are actually designed to understand how if you influence one food, how that actually changes body weight at a population level. So the kind of replacement studies, randomized trials, there was really only a handful that we had to even build that model, to where one thing is manipulated, but everything else is left free to vary, such that you can account for those compensations that occur in the real world. And so I think it would be great to see kind of a series of studies where we do the study in that context to better inform public health policies about obesity. And so with that, my acknowledgements, I'd like to acknowledge all my collaborators, ILSI for funding this work, and the UAB Nutrition Obesity Research Center for supporting me also while doing this work. Thank you.
We have time for a couple of questions.
Hi, I'll ask the cost question again. For every one of these sequences of probabilities, there are public policy interventions that could be used and perhaps refined to increase the chances of success. And I wonder if you're, in the future, thinking about coupling those kinds of questions.
So can you give me some examples of specific policies? I would love to hear about.
You can go to the tail end, where what you're spending to increase availability of leafy greens and farmers markets and that sort of thing. None of this stuff is cheap. In some cases, it's actually very expensive. But further up in terms of your probability chain, you have changes in appetite that people may be unaware of, but perhaps could better control if they were aware of it, using some of the apps and stuff like that. So there may be public policy interventions or changes in technologies that could more cost-effectively intervene along the probability chain.
Yes, thank you for that comment. I agree. That would be very interesting.
Richard Black, that was a really interesting talk. Thank you very much. I want to ask you a broad policy question. Nobody eats for the public health. Yeah? They eat for their own health. And all of the models that we see, though, are based on large data sets with many, many people, and hence really model public health. They don't model individual responses within those data sets. Is that a fair statement for me to make?
Yes.
Yeah? So given that, why do we care how an individual responds if we can show in a broad sense across the population that a particular policy has an effect?
So I think that's a good question. And I guess the issues I'm talking about as far as including, for example, behavioral or metabolic compensations in the model, you're right that that happens kind of at an individual level. But it's substantial enough in its effect size, and it's consistent enough from individual to individual, I think, to where the public health policy models also would merit from being informed by what is happening at the physiological individual level. And I think we just haven't connected those dots.
And so you do believe it could be integrated into the larger public health policy approach?
I think for obesity, it's almost required, because we are talking about weight change, which we know a lot more about it than we used to, and I think we just need to consider what we've learned. Thank you.
Thank you very much.
Samson, and with ADM. My topic very interesting, very important. The thing is, I'd like to know first things, do you have any inside idea for the obesity situation with prediction, the models? What will be next 5-10 years? So far, we tried so much, so hard. The soda intake decreased more than 50%. The sugar, the fat, all decreasing. But the problem, you mentioned it, is the diabetes, obesity, cancer, osteoarthritis. So many problems. This is keep moving up. So what's going to be next? The model prediction.
So I think as far as what will occur to obesity rates in the future, that would be best informed kind of course, by the past trends and the most recent trends. But as far as what's next, from my perspective, I really see that as you study obesity, what's been shown over and over again is that you don't see a reduction in body weight without some kind of intensive behavioral therapy. And so I think a lot of times we're focusing on policies that may help one or two people here and there eat a healthier food, but I think we need to really start focusing on policies that will make a sustained, measurable shift in an individual's energy balance to actually hopefully see a change in people's body weights. I would love to see policies personally directed more towards getting people access to the care that they need to help them make those behavioral changes. I think that we need to, of course, make the environment conducive to their success with those therapies. I think we're obligated to do that as a society. But I don't think that that alone is, just like with cancer policy, we focus a lot on prevention of reduction of exposure to cancer-causing chemicals. I think that makes a lot of sense for obesity too, removing exposure to those high-risk things. But we don't stop there with cancer, right? A policy around cancer is going to be about access to care, translating evidence to the most recent treatments we have. You know, even patient advocacy, making sure the patient is informed of what's happening to them. And so I would like to see us take public policy for obesity a step further, from not just in changing the environment to also enabling people to have access to the treatments they need to make a sustained change in their energy balance and therefore their body weight. So that's my take on kind of policy for the future and how to really change the trajectory that we keep seeing.